Hey legends, welcome back to the channel. We're starting off today's lesson with some flashbacks to the last video. See if you can remember how to find the exact values of these expressions. Pause the video, have a go. Okay, first one is sine 210. So we're saying to ourselves that 210 degrees, that's in the third quadrant. And because it's 30 degrees past 180, we're going to say it's 30 degrees in the third quadrant. In quadrant 3, if we think of our ASTC, third quadrant tan is positive, so sine and cosine are going to be negative. So from this we can say that sine 210 is going to be equal to minus sine 30. Okay, we're going to know our exact values, or we can draw up our triangles, but sine 30 is equal to a half, so sine 210 is equal to minus 1/2. Okay, for question B, cos 360. For questions like this, when they're multiples of 90, you've got to think of your graph. So if you can close your eyes and picture the graph of cos x, you might be able to see that the graph starts and ends at 1. So cos 360 is equal to 1, and we can see that from the graph of cos x. As I said in my sketching video, the sooner you have those shapes memorized, the easier some of these questions will inevitably be, especially for later lessons in this topic. Okay, question C, tan of minus 45. The trick for negative angles, we said that sine and tan, you can use the odd function property, which means that tan of minus 45 is equal to minus tan 45. Same thing for sine, and as we saw, cosine of a minus angle is just the same as the positive. All right, so tan 45 is equal to 1, so our answer is just minus 1. Okay, question D, we've got sine 570. So we said that because sine, cos, and tan repeat every 360 degrees, when you have an angle above 360, all you've got to do is take it back one loop by subtracting 360. So 570 take away 360 is equal to 210. This tells us that sine 570 is the same thing as sine 210. Which is good because we figured out sine 210 in question A. It's equal to minus 1/2, so we've already got our answer. Okay, cool. On to today's lesson, which is called Trigonometric Identities. So this lesson is going to be focusing on the algebra of trigonometry, which sounds horrendous, but it's pretty fun, I promise you. Okay, starting off by looking at some new trigonometric ratios. So far since year 9, we've been working with sine, cos, and tan using these fractions. Today we're going to introduce 3 new fractions. First one is called cosec. Okay, so cosec is defined as the hypotenuse side divided by the opposite side. So we're really just taking our sine fraction and we're turning it upside down. So most of the time when we're talking about cosec, we'll just be thinking of it as sine flipped upside down. If we take cos and we flip it upside down, so we have h over a, we call this sec theta. Okay, so sec theta is the reciprocal of cos theta. And our third one is cot theta, which is the reciprocal of tan theta, so it's adjacent over opposite. So these are our basic ratios, and these are going to be called our reciprocal ratios. Now there's a really easy trick to remembering which pairs with which reciprocal. It's called the third letter rule. If you look at the third letter of cosec, it's an S. So cosec is sine flipped upside down. Third letter of sec is C, and that's because sec is cos theta flipped upside down. And the third letter of cot is T, so cot is tan upside down. So we call it the third letter rule. Helps us remember which ratio goes with which reciprocal. Okay, up next, we're looking at what's called the tan identity. We used this the other day in our sketching video. It's that tan theta is actually the same thing as sine theta over cos theta. All right, let's see why this works. So we know that sine theta is, of course, opposite over hypotenuse, and cos theta is adjacent over hypotenuse. So what we can do is we can take this fraction and we can multiply the top and the bottom by hypotenuse, by h. The reason we're going to do that is because the h's on the top are going to cancel off and the h's on the bottom are going to cancel off because we've got times h and divided by h. What that leaves us with is O on the top and A on the bottom. So we've got O over A, which is our fraction for tan. So there you go. Tan theta is the same thing as sine divided by cos. It's a fact we're going to use a few times later in the lesson today. Okay, our next bit of algebra we can work with is called the complementary ratios. So remember from earlier in junior school that angles are complementary if they have a sum of 90 degrees. Okay, so if our two angles, x and y, sum together to give 90 degrees, a result we see is that sine x and cos y actually have the same value. This is why we've seen, like when we were doing exact values, we saw that sine 30 and cos 60 have the same value because 30 plus 60 makes 90. So to see why this works, we've got a triangle here. This is not a real triangle, by the way. These sides don't work with these angles, but anyway, it doesn't matter. If we were doing sine 40 here, so sine 40 is opposite over hypotenuse, so it's 3 over 5. If we did cos 50, we'd be doing adjacent over hypotenuse, so we get the same fraction. Okay, so sine 40 and cos 50 is the same fraction. Reason is that 40 and 50 together make 90 degrees. Okay, so we call these complementary ratios. We've got a couple others. This fact also works for cosec and sec. And a reminder that cosec is sine reciprocal, so flipped, and sec is cos flipped upside down. And it also works for tan and cot. So all three of these pairs have the same relationship of complementary angles. And if you need a reminder of what complementary angles look like, here is my depiction. Okay, sweet. This is pretty circumstantial, but it does come up and is handy every now and then. You never know. Okay, up next we got what's called the Pythagorean identities. These are a few equations that we're going to use in lots of questions to help us simplify expressions. Okay, the first one is we're looking at sine squared x plus cos squared x. The way we're going to do that is we're going to write sine as opposite over hypotenuse, and we're going to write cos as adjacent over hypotenuse. We're going to square both of those fractions and we're going to add them together. Okay, if we square o over h, we get o squared over h squared. Likewise, we get a squared over h squared here. Now, because the bases match up, we can add the numerators. So we get o squared plus a squared over h squared. Now let's have a look at a right angle triangle very quickly. Here we have opposite, adjacent, and hypotenuse. What do you think is going to happen when we do opposite squared plus adjacent squared? Well, given that these are called the Pythagorean identities, what we're going to get is hypotenuse squared. O squared plus a squared is equal to h squared. That's Pythagoras. So at the top of this fraction, we can actually write this as h squared. So we get h squared over h squared, which is equal to 1. So it's a cool fact that no matter what this angle x is, as long as it's the same angle and you're doing sine squared plus cos squared, the answer is always going to be 1. Isn't that just so amazing? Maths is beautiful. All right, so there's our first Pythagorean identity. We're going to re-express this in a couple of other ways that can also be useful. So there's our first one. What we're going to do is we're going to take this equation and we're going to divide each term by cos squared first, cos squared. Okay, how can we write this? So obviously cos squared divided by cos squared is going to be 1. What's another way of writing sine squared over cos squared? Well, remember from earlier in the video when I said that sine over cos is equal to tan. This means that sine squared over cos squared will be tan squared. Over on the right hand side, also from earlier in the video, we said 1 over cos is the reciprocal of cos, which is sec. So the right hand side, we can write this as sec squared. Okay, so we're using these two facts to write this as tan squared, this as 1, and this as sec squared. And now we have our second Pythagorean identity. So sine squared plus cos squared is equal to 1. But another way of writing this is tan squared plus 1 is equal to sec squared. Now this is a equation that I always really struggled to memorize for some reason until one of my students, Mr. Chenglin Wu, said something that I will never forget. He said, "Sir, this 1 is just a man and a tan is sexy." And I was like, you know, Chenglin, I just honestly can't disagree with that, and I've never forgotten it to this day. So a man and a tan is sexy. It works. And look, it's true. Look at this, God. All right, up next, let's get another one. Starting with our sine squared plus cos squared once again. This time, we're going to take all three terms and we're going to divide by sine squared. Okay, so similar process. All right, so sine squared divided by sine squared is going to give us 1. Over on the right-hand side, we know 1 over sine. We can write this as cosec. Okay, third letter rule. So 1 over sine squared, we can write this as cosec squared. Now the tricky part here is that we've got cos squared over sine squared. So we said before that sine over cos is tan. So if we flip it upside down and we have cos over sine, this means we've flipped tan upside down, so we've got cot. All right, so we're using that 1 over sine is going to be equal to cosec, third letter rule. And we're using that sine over cos is tan, so cos over sine must be cot, which is tan flipped upside down. Okay, so a lot of info in this video. Hope I'm not going too fast for you guys. So this expression we can write as 1 plus cot squared is equal to cosec squared. Okay, and the way I remember this one is that, again, the 1 is a man, and a man in a cot is cozy. So there you go. We got a man in a tan is sexy, but a man in a cot is cozy. And there we go. And this one's pretty hard to forget because look how beautiful it is. Sine squared plus cos squared, always equal to 1. I love it. Okay, so here are our 3 identities. We're just going to look at some other ways that these can be written to try and confuse us. So sine squared plus cos squared is equal to 1. This means another way of expressing this formula, we could move it around and instead do 1 take away cos squared, and that would give us sine squared. Likewise, if we did 1 take away sine squared, that'd be an expression for cos squared. Okay, so these two right here are just an alternative form of this equation, which we're going to see later on. All right, so keep an eye out for this, but also keep an eye out for these two as an alternative way of writing cos squared and sine squared. Okay? Getting comfortable with these equations, it just takes practice, unfortunately, so we got to put in some time. Okay, for the second equation, tan squared plus 1 is sec squared. Again, we could write this as tan squared equal to sec squared minus 1. So there's an alternative arrangement of this green formula. And for the last one, another way of writing this, we could put the 1 over the other side and say cosec squared take away 1 is equal to cot squared. Same thing, just rearranged. Okay? So we've got to keep an eye out for these 3 equations, but also if we're really switched on, we can try and watch out for these ones as well, because they can be useful. Okay, there's the info for today's lesson. Let's have a go at some examples to try and help build some confidence. So first up, we have sine theta is equal to 3 over 8, and tan theta is negative. Find the exact value of these 4 expressions. Okay, so we're trying to go from sine theta to cos theta. We've done this a couple of times in previous lessons. I showed you guys that the best way to do this neatly is to make a right angle triangle. So I've got a triangle over here. We're going to make this angle here theta. And so if sine theta is equal to 3 over 8, well, we know that this means that the opposite side will be 3 and the hypotenuse will be 8. So we'll write a 3 here and an 8 here. All right, sweet. So now to find cos theta, we need to find the adjacent side. So we need to do some backwards Pythagoras. So we'll do 8 squared is 64, 3 squared is 9. So 64 take away 9 is going to be 55. And then we'll do the square root of 55 just here. Okay, what we also need to be aware of is what quadrant our angle theta is going to be in. So the question says that sine theta is positive 3/8 and tan is negative. So in which of our 4 quadrants are we going to have sine being positive and tan being negative? Well, we've got to be in quadrant number 2. That's where sine is positive, but tan and cosine are going to be negative. This is important because for question A, for cos theta, we're not just going to do root 55 over 8. Because we are in quadrant 2, we need to have a negative with our answer. Okay, so because we're in this quadrant, tan and cos are going to be negative. Cos is adjacent over hypotenuse. Okay, sweet. Up next for B, we've got cosec. All right, so the third letter of cosec is S, which means that cosec is sine, just flipped upside down. So if sine theta is 3 over 8, cosec theta will be 8 over 3, just sine upside down. Okay, question C, we have sec theta tan theta. What this really means is sec theta multiplied by tan theta. Okay, so sec theta, third letter is C. So sec is going to be cos flipped upside down, which is convenient because we have cos just here. So if this is cos theta, sec theta will be negative 8 over root 55. Okay, tan theta, we're going to get from our triangle. So opposite over adjacent is going to be 3 over root 55. Again, don't forget, we are in quadrant 2 for this angle, and the question already reminded us that tan is going to be negative. So we're going to do opposite over adjacent, but we need to have a negative with our answer. All right, two negatives are going to make a positive. 3 8s are 24, and then square root of 55 squared is just 55. So our final answer for sec theta tan theta is 24 over 55. Okay, for D, we have cot squared. So third letter of cot is T, which means cot is tan flipped upside down. And then we're going to square it. So cot squared means cot times cot, basically. All right, so tan was just here. It was our minus 3 over root 55. So we're going to flip that upside down and put the root 55 on top and the 3 on the bottom. And then we're going to square it. Squaring a negative gets you a positive answer. So we're going to get 55 over 9 as our final answer for cot squared. Okay, awesome. Up next, we have an equation. We are going to solve for x. We have tan 20 is equal to cot of 2x minus 30 degrees. Okay, so this looks very scary until you remember from earlier in the lesson that, hey, tan and cot are a pair of angles with that complementary angle property, where we said that the two are going to be equal if the angles are complementary. So just like sine and cosine, tan and cot are going to be equal when the two angles have a sum of 90 degrees. Okay, so we can use this fact to make a simpler equation. We know that 20 plus 2x minus 30 should give us an answer of 90 if tan and cot are going to be equal. Okay, complementary angles. So now we've gone from a very hard equation to a very easy equation. We can just do 20 take away 30 is minus 10. Add the 10 across and we get 2x is 100. And so we get our answer of x equal to 50. All right, so if 10 is 20, 2x would be 100, take away 30 is 70. 70 and 20 are complementary, so the relationship works. Okay, up next, we're doing some real trig algebra now. We're going to simplify these expressions as best we can. So simplifying expressions, when you're new to it, it can be a bit of trial and error, but it just involves you writing trigonometric expressions as alternative forms that you can think of. Okay, so let's look at this first one. What can we change here? Well, let's think about sec theta. What do we know about sec theta? Well, we know the third letter is cos, so that means that sec theta is actually 1 over cos theta. Okay, so we can write sec theta as 1 over cos theta. Now 1 over cos times cos, that's going to get us cos over cos. And anything divided by itself is just 1. So the simplified expression of sec theta cos theta is just 1. Okay, over on the right we have 1 minus sine squared multiplied by tan squared. All right, what can we do here? We could write tan squared as, well, we know that tan can be written as sine over cos. That could be useful. What about 1 minus sine squared? Is this familiar? Well, let's think. From earlier in the video, we said that sine squared plus cos squared is equal to 1, yeah? That was our Pythagorean identity. If you rearrange that, you're going to get 1 minus sine squared is equal to cos squared. Okay, if you flick back through your notes on a previous page, you'll see 1 minus sine squared is equal to cos squared. So we've simplified that a little bit. Now, like I said, we can write tan squared because tan is sine over cos. We can write this as sine squared over cos squared. Okay, tan squared as sine squared over cos squared. Now the cos squared here and the divided by cos squared here are going to cancel each other out, leaving us with a final answer of just sine squared. So there is our simplified expression for the question right here. Like I said, a pretty high degree of difficulty for these questions. When you're new to them, it is pretty scary, but you just got to start off slow and build up confidence. Okay, a couple more examples to help build some confidence. So first up, we have 1 over cos squared, take away tan squared. Again, we're trying to simplify as best as we can. So let's think about what we could be doing with this one. 1 over cos squared, I guess we could write that as sec squared if we wanted to. It's probably not going to get us anywhere good. What's going to be a bit better would be writing tan squared x, once again, as sine squared over cos squared. Okay, so tan squared is sine squared over cos squared. Reason this is good is because now we have two fractions that have the same denominator, so it makes them easy to combine. So we can write this second line as 1 minus sine squared all over cos squared. Okay, awesome. Now, looking up top again, where have we seen 1 minus sine squared before? We use this in the previous question. 1 minus sine squared is another way of writing cos squared. Okay, so we're taking our sine squared plus cos squared equals 1, rearranging it, and we get 1 minus sine squared equal to cos squared. So we have cos squared divided by itself, so we end up with just equal to 1. So our question was just equal to 1 after all. Okay, and question D, we have sine squared take away sine squared cos squared x. All right, what can we do here? Well, I suppose we have a common factor, don't we? We have two terms that both have a sine squared in them. So why don't we just factorize and see where we go? So we'll factor sine squared out of both terms, leaving us with 1 in the first term and cos squared in the second term. Now, looking at inside of our parentheses, we have 1 minus cos squared. What do you reckon we can write 1 minus cos squared as? That's correct. We can write 1 minus cos squared as sine squared. So we have sine squared x multiplied by sine squared x. So we end up with sine to the power of 4x. Okay, the reason this is simplified is because we've gone from 2 terms to 1 term. Even though the power is higher, it is a little bit nice and tidier. All right, awesome. To finish off today's lesson, we're going to do some proof questions. All right, these are usually pretty challenging, so let's try and go as slow as we can. So we are trying to show that this equation makes sense. We're trying to show that the left-hand side and the right-hand side of this equality are the same thing. Now, what you want to try and avoid doing is taking both sides of the equation and just playing around with them until they match up. Okay, that might work, but it's not the proper way of proving a mathematical statement. If you want to prove it properly, you've got to pick one side. So start with the left or start with the right and show that you can make it equal to the other side. All right, so I'll show you what I mean. We're going to start off with the left-hand side, LHS, equal to sec theta plus tan theta. All right, we're going to see if we can try and make this look like 1 plus sine theta over cos theta. All right, cool, here we go. So sec theta, so keep in mind that in our target, we're aiming for sines and coses. So that's what we should be trying to turn our left-hand side into. So let's write sec theta. Third letter is cos. So sec theta is 1 over cos theta. And once again, very usefully, tan theta is sine over cos. So sec is 1 over cos, tan is sine over cos. Now we have two fractions with the same base. We can add the tops together and get 1 plus sine theta is equal to cos theta, which is what we were trying to prove. So we have proved that the left-hand side is equal to the right-hand side as required. Okay, so if you're just playing with both sides and then showing that they end up at the same thing, it's not a proper proof and you probably won't be getting full marks for it. So you want to start with one side and show that it's equal to the other. Okay, cool. Same thing for question B. We're going to start with the left-hand side equal to 1 plus tan squared. We're going to try and see if we can make that look like 1 over 1 minus sine squared. Okay, cool. So what can we do? Well, once again, why don't we just use one of our Pythagorean identities? So remember that a man and a tan is sexy. So 1 plus tan squared is equal to sec squared. Okay. Now, what's another way of writing sec squared? Well, again, sec is 1 over cos. So sec squared is 1 over cos squared. And now what's the final link? How can we turn 1 over cos squared into 1 over 1 minus sine squared? Well, yeah, once again, we can use our Pythagorean identity and use that 1 minus sine squared is equal to cos squared. And so we can just go there in one hit. And then we have left-hand side is equal to right-hand side as required. So we've done the question. Okay, so we're using our Pythagorean identity here, writing sec as 1 over cos, and then using cos squared is equal to 1 minus sine squared. All right, that's what we're going to leave it for today's lesson. Some more practice for you guys to have a go at in 902. See how you go, don't rush, very challenging exercise, so please let me know if I can give you some more help. Otherwise, I'll catch you guys later on in the week. Thanks for watching.